Hi guys, this is another video about the CSS Pure Mathematics Exam from 2023, and we are still on section A, and we are going to solve question 2, item A. So let's read the question. For any group G, show that the quotient group G by this set here, whose unique element is the identity E, is isomorphic to G, and show that the quotient group G by G is isomorphic to the set whose only element is the identity element. Okay, as we will see, this question is a straightforward application of the first homomorphism theorem for groups. So let us recall the statement of this theorem and let's see what we can do with it. So this theorem tells us that if we have two groups, G and H, and a homomorphism from G into H, then the kernel of this homomorphism is a normal subgroup of G. The image of this homomorphism is a subgroup of H, and the image of phi is isomorphic to the quotient group G by the kernel of phi. So just recalling what is the kernel and the image, if we let EH be the identity element of H, the kernel of phi is the set of all elements in G, such that when I apply phi, I get the identity element of H, EH. And the image is the trivial definition, is the set of all elements in H of the form phi of G. So all elements which are images of some element in G, or elements in H which are images of elements in G under phi. Okay, so now let's see how we can apply this result to solve our problem. So let's go. So first we are going to construct two convenient mappings which we will see that are homomorphisms. So I get this mapping phi from G into G, which takes an element G into itself. And I have this other mapping psi, which takes every element G into the same element E, which is the identity element of G. Okay, so now we can easily see that phi and psi are homomorphisms. Why? Because if we get any elements G and G prime in G, and we apply phi, we obtain that phi of G times G prime is, since it takes an element into itself, we get here this, and then since G is phi applied in G, we can plug this here, and then we plug this here because G prime is the same as phi of G prime. And now for psi, if we apply psi to any element to G times G prime, we get the identity element, but the identity element is the same as the identity times the identity. So we can, and this is the same of psi of G times psi of G prime. Okay, so psi and phi are homomorphisms. Now, another trivial thing to see is the kernel of phi is E, is the set whose only element is E. Well, why? Well, because it's the identity mapping. It takes each element into itself. So the only element which can be taken into E is E itself. And the image of phi is G, because if every element in G is itself, so which is phi of G. And now for psi, the kernel of psi is G, because every element in G, when I apply psi, I get E. So they're all in the kernel. And the image is E, because every element, the psi of every element of every G in G is E. So this is easy. Now all we need to do is apply the first homomorphism theorem for groups. So if we take H in the theorem the same as G, we get that G, the quotient group G by this set here, which is the same as the quotient group of G by the kernel of phi, is isomorphic to the image of phi, but we have already seen that this is G. So we get what we wanted. And again, the quotient group G by G is the same as the kernel of G, is the same of G, the quotient group G by the kernel of psi. And by the first homomorphism theorem, this is isomorphic to the image of psi, which we know that is this set here. And we are done. So it's not a complicated problem. It's a bit, to me, it's a bit complicated to explain, but it's not complicated. When we see it written, it's pretty clear. So I hope you enjoyed this video, and please leave me a comment, subscribe, and give me a thumbs up. I would love to hear what you think of these videos. I'll be posting more as soon as I can. Thank you very much. Bye.